So we have reached till time 5 nanosecond, and let's advance it for few more iterations. So this was your final state of variables at the end of 5 nanosecond. And let's see what happens at 10 nanosecond. So at 6, 7, 8 and 9 nanosecond there are no difference, because the next code that is getting executed will be the 4-hour block, which is again waiting for 5 more time units. And while coming into 10 nanosecond, the state of variables will be clock will be equal to 1, TB opcode is 1, and interface opcode is again 1, and data is equal to X. And in the active region of 10 nanosecond, the 4-hour blocks will be triggering, and it will be changing the clock value to 0. It will toggle the clock value, so it's a blocking assignment, so the clock values will be changed to 0 here. So but since it is changing to 0, and all of our wait statements and the clocking blocks are sensitive to positive edge of clock, nothing will happen. At 10 nanosecond, only the clock value variable will be assigned to 0. So again, simulation will continue to 11, 12, 13, 14, and at 15 nanosecond, the next set of events will happen, because that is the time when that clock is again getting changed to 1. So in the 15 nanosecond, in the prepoint region, clock is 0, TB opcode is 1, interface opcode is 1, and data is equal to X. And these are the relevant part of this module and design code, the test bench and design code. So at this point we are in this particular wait. The first wait was already satisfied at 5 nanosecond, and this is waiting for next clocking event. So at 15 nanosecond, initially the 4-hour block will be changing the clock to 1 in the active region. Since it is changing to 1, it is happening the positive, it is detecting the positive edge of clock, and this always block will be untriggered. So in the active region itself, the case statement will continue execute, and at this point the interface opcode value is already 1. Therefore it need to trigger this statement. So this is a matching statement. So this is again a NBA assignment, non-blocking assignment. So this will evaluate the RHS of this NBA assignment in this active region at this point, and after coming to the NBA region, this assigned RHS will be assigned to this. The evaluated RHS will be assigned to the LHS of this expression. Thus, interface.data will be equal to TH11 at this point when it is reaching NBA region. Again, this clock was getting changed from 0 to 1, so this will trigger the clocking block of the interface. So that will again untrigger this particular wait, and as we have already discussed in the previous video, since it is untriggering, it need to execute one more NBA assignments, but since it is already past the observed region, no feedback is possible at this point. Therefore it will schedule an feedback loop at the end of this iteration to the active region, and again this interface.cb opcode will be updated to 2, because it is an output variable of this clocking block. So this will happen at re-NBA region, and after that it will go back to this this active region loop because of this statement, this TB opcode assignment, and it will again assign it to first the LHS will be evaluated, then the RHS will be evaluated, then the LHS will be assigned with the value 2. So at the end of 15 nanosecond, your TB opcode will again get changed to 2, and this is the state of variables at 15 nanosecond. So your clock is 1, TB opcode and opcode are 1, and also your data value is also changing from X to 1. So that is because of this particular design module line. So here I am winding up this explanation. Now from this point onwards, this set of event will continue to execute. So this was quite a simple code to explain. So you have already seen that with this simple code itself, how many set of events are happening. So you can imagine in a large TB and RTL design code simulation, how many events and how many evaluations will happen. So all of them are handled by the complex simulators. You don't really need to think about how this will work in simulation, but whenever some erroneous situation happens, you can go into the code and analyze what will happen. Say for example, if you have added a hard zero delay in between, sometimes it is giving unexpected behaviors and so on. So I hope these concepts are clear for you now. If you follow the coding practices that we have already discussed in this course, then most of the time your simulation will run smoothly and you don't need to worry about all these simulation regions in depth.